So this assignment was reviewing what we learned about circles up until this point. So we were reviewing information about arcs, chords, inscribed angles, and parts that show up inside our circle, perhaps some right triangles, solve for some missing pieces. So in our first scenario, we're given our circle, X. Remember, circles are named by the center, so I'm just going to go do a quick review of what we know about our problem. So the center of our circle here is at X. Then we know other pieces about our circle. They said segment DC is congruent to AB. Well, DC and AB, those segments have their endpoints on the circumference of the circle. That makes them chords. And we know that these two chords are congruent to each other based on the givens. So then, a couple other things that we know. We said if the chords were congruent to each other, then their intercepted arcs would be congruent as well. So the measurement of arc AB would be congruent to the measurement of arc DC. Then they told us the radius is 20. So again, by definition, the radius of a circle goes from the center of the circle to a point on the circumference of the circle. Currently, we don't see any radii drawn in, but we can always do that ourselves because we know where the center is, and we do have some points on the circumference of the circle. So we can draw some radii in from X to D, X to C, X to B, and X to A. And we know that the radius can be drawn from the center of the circle to any of those points on the circumference, and they'd have to be the same distance to each other. So we know that distance is 20, so we could fill that in our picture as well. Now, based on what we have so far, we can see we do have some right triangles being formed within our picture because we do see the right angle here at XTC. And if this is 90 degrees, right, this is a linear pair, so that means total 180, which means there'd be a right angle here. So we have two right triangles. Then we have another right angle here at XSB, and again, the same idea as what's happening in our previous picture, right? Linear pair, if this is 90, the total has to be 180, that would have to be 90 as well. We're also given another piece of information that angle TXC is 30 degrees. So TXC, that's this angle right here, that's 30 degrees. We could label that in our picture. So we have some more information that we could be working with. We've got our right angle, we've got our 30-degree angle here. We have a right triangle here at XTC, which we could figure out this other angle if we'd like. We've got another right triangle here at XTD, and we can look at information for those as well. And hopefully we're seeing some more patterns that result with our triangles. Now, besides the individual right triangles, we have some larger triangles here, DCX and also AXB, and notice that both of those triangles have two radii making up the sides of the triangles, and we already knew that DC was congruent to AB. Therefore, triangle DXC and triangle AXB would be congruent by side, side, side. That might be helpful as we do some more solving going forward. So let's see what some things that they want us to look for. We want to know segment DT. So we're looking for this piece of the chord for DC. So let me kind of highlight that piece again here. If we had extended XT all the way to the circumference of our circle, that would be another radius. However, it stops here on our segment. But notice, what is that helping us with? This segment here, XT, is now shared by both of these two right triangles. And so it's nice because this is a reflexive, right? So it's got to be congruent to itself. We have our two radii being congruent. And we've got a right angle congruent. Well, these are the hypotenuses, right? This is a leg for a right triangle. These two triangles will be congruent by hypotenuse leg. What's also nice to remember is that when a radius is perpendicular to a chord, it bisects that chord. That means DT would have to be congruent to CT. Well, we already said that this triangle was congruent to this triangle. And notice the same situation is happening here. If we extended XS, that's another radius, would bisect the chord again. And so since those triangles were congruent, then their pieces would be congruent by corresponding parts. We have some more information to work with. Now dt, right, that's what we're focusing in on. We said we've got congruent triangles here, which means that the corresponding parts are congruent. So if this is 30 degrees, that would be 30 degrees as well. And we could use that to help us find this length for our triangle. So let's focus in on this triangle, dxt. And what do we know about it? Well, for that right triangle, we have a hypotenuse of 20. We have an angle here of 30. We've got our right angle, and here's dt. So the question is, how can we find the length for dt? Well, we know when it comes to right triangles, we always have several different ways that we could solve them. Perhaps you're thinking to yourself, well, we know that we've got one angle being 30, we have another angle being 90, the total has to be 180, that means this angle has to be 60. Well, that's helpful because we know in 30, 60, 90 right triangles, there's two patterns that we could follow to help us find the missing lengths. We know the hypotenuse is related to the short leg. It's double the amount. We also know that the median leg, remember the median leg is across from your 60-degree angle, the short leg's across from the 30-degree angle. The median leg comes from the short leg times the square root of 3. These are going back to those ratios that we were talking about, the 1, square root of 3, and 2 previous units, and we keep coming back to that again. So if we think about what we have here, we said the hypotenuse is 20, so I could fill that in. And the short leg, well, that's across from the 30-degree angle. That's dt. That's what we're looking for. And we know, again, the short leg times 2 is the hypotenuse. So if I fill in what I know, right, here's the hypotenuse. dt represents that short leg times 2. Now we have this pattern that we can undo. Well, it's supposed to be double, so for multiplying by 2, to undo that, we would divide by 2. And 20 divided by 2 would be 10. So our segment dt here has to be 10 units in length. Now, some of you may say, well, I didn't remember the ratios, or if you want to talk about your 30, 60, 90 patterns, there's still another way that we could do it, right? Right triangles, we've got our three ratios. We could do sine, cosine, or tangent. So let's think about where we are. If we're standing here at 30 degrees, dt is opposite, and we have the hypotenuse. Well, opposite and hypotenuse uses the sine function. So we could have said that the sine of 30 degrees is equal to dt over 20. So again, we're just undoing the equation to solve for dt. So if we were dividing by 20, to undo that, we can multiply by 20 and do our calculations, and 20 times the sine of 30 degrees gives us our 10 units in length.